Welcome to a slow, beginner-friendly lesson on configuration and environment variables in Python, made for absolute beginners. Code stays, settings change. Today you separate configuration from code. Real programs read settings from outside, an API key, a file path, a feature flag, a database URL. When you hard code these, the same code cannot run in two environments. When you read them from the environment, the code stays identical and only the settings change. We start with os.environ, the dictionary of environment variables, then meet the .env file pattern that keeps settings in a file you never commit. Settings outside the code. Here is the project. A folder called my project with pyproject.toml, two Python files called config.py and main.py, and one special file called .env-example. The .env-example file is a template. It lists every setting your program needs, with fake placeholder values. The real .env file is created by each developer and is never committed to Git. We will see why by the end of the lesson. Plus a .env example. Create the project with uv-init my project, then add the python.env library with uv-add python.env. This small library reads a .env file and loads its values into os.environ for you. The standard library os module gives you access to environment variables directly, but python.env makes the .env file workflow smooth. Move into the folder and open the two Python files. Add python.env. Before you can run, copy .env example to .env. The .env file is your local settings file. Open it and fill in real values, your API key, your file path, your flag. Then run the program with uv-run python main.py. Python.env reads the .env file at startup and exposes every value through os.environ, just like real environment variables. If you skip the copy step, the values are missing and the program tells you. Copy, edit, run. Your code is the same in every environment. Only the settings change. Same code, every environment. Configuration is anything that might change between environments. Your development machine, a test server, a production server. API keys differ. Database URLs differ. File paths differ. Feature flags differ. Timeouts differ. If a value could ever be different in another environment, treat it as configuration. Read it from outside the code. Anything per environment. Why separate config from code? 3 reasons. 1. The same source code runs unchanged in development, staging, and production. Only the settings differ. 2. Secrets like API keys and passwords never enter version control, where they could leak. 3. You can change settings without editing code, which means deployments do not require a new build. Configuration belongs outside the program. 3 solid reasons. Open a Python file and import os. Os.environ is a dictionary-like object that holds every environment variable. Read a value with square brackets. Os.environ square brackets user gives your operating system username. Every value is a string. Even numbers come through as strings, which means you have to convert them yourself with int or float when you need a numeric type. We will see that conversion soon. The environment dictionary, reading with square brackets raises a key error if the value is missing. For configuration you usually want a default instead. Use os.getInf. Pass the variable name and a default value. If the variable is set, you get its value. If not, you get the default. Notice the second example, we read timeout as a string with default 30, then convert it to an integer with int. Environment values are always strings. Convert where needed. Avoid the key error. Every program runs inside an environment that carries key value pairs from outside the code. The environment holds values. Here is what a .env file looks like. The .env example file lists every variable your program expects, with placeholder values. The real .env file has the same variables, but with real values. The example file is committed to Git so other developers know what to set. The .env file is Git ignored so secrets never leak. Each developer copies the example to .env and fills in their own values. A simple template. Inside main, import load_.env from the .env module. Call load_.env near the top of the file. The function reads .env from the current folder and loads every value into os.environ. After that, you read values exactly as you would read real environment variables, with os.getInf. To a downstream reader, there is no difference between values from the .env file and values from the real environment. Load the file. Environment values are always strings. When you need a different type, convert explicitly. For an integer timeout, wrap with int. For a Boolean debug flag, read the string, lowercase it, compare to the string true. For a list of ports, read the comma-separated string and split on commas, then convert each piece to int. Keep the conversions next to the read so the intent stays obvious. Strings to numbers. API keys and passwords belong in the environment, never in a source file. Secrets never live in code. Trace how a value moves from outside the code to inside. The .env file holds the key value pairs. Load_.env reads the file and writes each pair into os.environ. Your code calls os.getInf to read a value. The value comes back as a string, so you convert it if you need a number or boolean. The code never opens the .env file directly. Python.env handles the file. os.getInf handles the lookup. Your code handles only the use. From file to code. Instead of reading environment variables in every file, centralize the reads in a config module. Config.py loads.env once, then exposes constants with proper types and defaults. API_key is a string. Timeout is an integer. Debug is a boolean. Other modules import these names directly. One source of truth. If a variable name ever changes, you update one file. Centralize reads. Never write a real secret in source code. The line API key equals sklib abg123 is the classic mistake. 3 problems. 1. Anyone with read access to the repository can see the key. 2. Git history keeps it forever, even after you delete the line. 3. Automated bots scan GitHub for leaked keys and abuse them within minutes. Read secrets from the environment with os.getInf. The secret lives in .env, which is git-ignored, or in the real shell environment. Never do this. Add .env to your .gitignore file. This tells Git to ignore the file completely. The real .env never enters version control. The .env example file is committed, because it has no real secrets, only placeholders. Other developers clone the repo, see the example, copy it to .env, fill in their own values. The pattern keeps secrets local while making the required settings obvious to everyone. Protect your secrets. Some habits that pay off. Keep all environment reads in one config module so there is a single source of truth. Always pass a default to os.getInf so the program starts even when a variable is missing. Commit .env example for discoverability, but always git-ignore the real .env. Cast values explicitly to int, float, or bool right after reading, so the rest of the code can use them as the right type. Habits that pay off. Configuration is anything that changes between environments. Read it from os.environ using os.getInf, which lets you pass a default and avoid key error. The .env file pattern stores settings in a file that is git-ignored, while the .env example template is committed so others know what to set. Centralize every read in a config module so the rest of your code imports clean constants. Configuration in one breath. Next lesson is the capstone. You build a small command line tool that uses everything from this phase: modules, type hints, the src layout, logging, and configuration. The tool reads a setting from .env, logs what it does, handles errors cleanly, and runs from the command line with arguments. After the capstone, phase A.9 is complete. Then we move to testing and packaging. Capstone comes next. If you want a quick practice, add a new variable called max_retries to both .env example and your local .env, set to 3. Read it in config.py with os.getInf, default to 1, and convert to int. Import it in main and print a message saying how many times the program will retry. Run the program and confirm the value 3 appears. Change the .env value, rerun, and watch the output change without touching the code. Read one more variable. Quick self-check. Can you explain in one sentence why configuration should live outside source code? Can you write an os.getInf call that returns a default when the variable is missing? Can you describe the difference between .env and .env example, and which one is committed to Git? Can you cast a string environment value to an integer? If any feels shaky, rewatch the matching part. Say each out loud. Thanks for learning how to separate configuration from code. Next we pull everything together in a capstone command line tool. See you in the capstone.